Hi everyone, my name is Kirtika Sharma and today I'll be presenting on QUIC, which stands for Quick UDP Internet Connections. This protocol presents a modern approach to transport layer communication, addressing the limitations of traditional protocols like TCP and offering significant improvements in terms of performance and efficiency for internet applications. So let's begin. QUIC is a connection-oriented transport protocol designed by Google. Unlike TCP, QUIC is built on top of UDP, which allows it to avoid many of the performance bottlenecks associated with TCP. QUIC's design focuses on reducing latency, improving connection establishment feed times, and providing integrated security features, making it ideal for modern internet connections applications. So, QUIC's functionalities and frameworks are like these. QUIC brings several innovative functionalities to the table. One of its key features is the ability to multiplex multiple data streams over a single UDP connection, which enhances data transfer efficiency. QUIC also employs advanced congestion control algorithms that adapt to network conditions, optimizing data transmission. Moreover, QUIC prioritizes security by integrating encryption and authentication mechanisms directly into the protocol, ensuring data integrity and confidentiality. Regarding frame formats, QUIC uses various frames such as stream frames for carrying application data, ACK frames for acknowledging received packets, and connection close frames for terminating connection. This flexible frame format structure allows QUIC to handle a wide range of data transmission scenarios effectively. Let's move ahead. Compared to TCP and other protocols, QUIC offers several advantages. It significantly reduces latency for both connection establishment and data transfer, which is crucial for real-time applications. QUIC ability to manage multiple streams efficiently results in better performance over congested networks. Additionally, the protocol's built-in encryption and authentication provide enhanced security, making QUIC a robust choice for modern internet communication. However, QUIC also has its disadvantages, such as limited adoption and potential compatibility issues with older network infrastructure. Additionally, the complexity of QUIC's implementation can make debugging and deployment more challenging. QUIC is already being used in several network applications. One of the most notable examples is web browsing, where QUIC's performance benefits lead to faster page loads and smoother user experiences. Video streaming services also benefit from QUIC ability to handle multiple streams effectively, ensuring high definition content with minimal interruptions. In the realm of online gaming, QUIC's low latency and reliable data delivery enhance responsiveness and reduce lag, which is crucial for a seamless gaming experience. Additionally, QUIC's congestion control mechanisms and secure communication features make it an excellent choice for file sharing services. So, I hope you have got till here. Let's move ahead. Sorry for the interruption. Okay, give me a second. Okay, so moving ahead to the scalability. Scalability is one of the QUIC's strongest features. It allows multiple streams to be multiplexed over a single connection, reducing the overhead associated with establishing separate connections for each stream. Additionally, QUIC supports load balancing, where connections can be distributed across multiple servers, improving overall performance and resource utilization. QUIC's support for multipath routing is another critical scalability feature, allowing data to be transmitted over multiple network paths, enhancing resilience and increasing throughput. These features make QUIC highly scalable, ideal for large-scale applications such as content delivery networks and cloud services. Okay, let's come to the very interesting part of the whole video today. So in this section, we will be exploring QUIC through a hands-on analysis using Wireshark. First, we're going to capture the network traffic and filter for QUIC packets, and then we're going to examine it out. I hope you would like it. So let's start. Okay, so let's first search out the Wireshark. So here I have already launched the Wireshark. Next, okay, so before doing it, first we'll be setting it up. I'll be analyzing QUIC over my Wi-Fi. Okay, so let's clicking it out. Now it's capturing a lot of packets, right? You can see it here. In this session, we'll generate a QUIC traffic, capture it with Wireshark, and analysis key aspects like the QUIC handshake, frame formats, and packet transmission. Okay, so to begin the recording, okay, now next, well, what we are going to do, next, I'll open a web browser. So let's go to the Google. Next, okay, so as I've already opened here a Google Chrome, so www.google.com. If you don't want it, let's do it again first. So you open a web browser, just take an example. Anyway, I'm just gonna use the google.com. Yep. As Google services are known to implement QUIC, so as I interact with the website, Wireshark is capturing all the packets. So I'll show you here. So you can see it's capturing a lot of packets. After a few moments, I'll return to the Wireshark and stop the packets. I can stop it or let it be like that. Okay, so to focus on QUIC packets, I'll type QUIC into the Wireshark filter bar and press enter. Okay, so QUIC, press enter. One of the first things we'll look at is the QUIC handshake process. I'll scroll through the captured packets. By expanding the packet details, now we can see how the client server exchange connection parameters, negotiate encryption keys, and establish a secure connection. This process is significantly faster than the TCP handshake thanks to the QUIC's zero RTT connection establishment. Okay. Next, let's take a look at the different framework used by QUIC. I'll select a packet here. Different frameworks, which is usually labeled as a stream frame. Expanding the QUIC protocol layer. Here we can see how QUIC uses different frames typed for carrying application of data. QACK frameworks for acknowledging received packets, and connection close frame for terminating a connection. The flexibility of these frames allows QUIC to handle a wide range of data efficiency. So let's close that. So through this process, through this analysis, we have seen how QUIC significantly improves upon TCP by offering faster connection establishment, flexible frame formats, and robust congestion control. Capturing analysis QUIC traffic with Wireshark provides us with a deeper understanding of how this protocol operates in real-world scenarios. This practical experience not only reinforces the practical knowledge we have covered, but also highlights the tangible benefits of QUIC in modern network connections. So if you have any questions, you can just comment it out in the channel. Okay, now next, moving ahead. coming back to my presentation. So that was these are the security threats I have mentioned here for you: DOS attacks, man in the middle attack, session hijacking, protocol vulnerabilities. Okay, so go ahead. So this we have already seen in the hands-on analysis activities. So what we are seeing is QUIC adoption and future outlook. QUIC adoption is growing rapidly with major web browsers and content delivery network supporting the protocol. It's expected that it may become the dominant internet protocol in the near future, and hopefully it will be, because it can be seen, as we have seen, that it is really becoming on high scale, right? Coming to the browser support, Chrome, Firefox, Edge, Safari, all are supporting the QUIC, so that it can enable the users to experience its benefits on a wide range of devices. Content delivery networks are increasingly integrating QUIC into their infrastructure, enhancing content delivery and reducing latency. So basically, the future of the internet, QUIC has the high speed, security, efficiency. That, of course, might bring it on the large scale and has a good scope for the future. So that's all about the today's. Thanks for watching. If you have any doubts, you can just comment it out. I'll get back to you as soon as possible. I hope you get whatever is being covered today. That's all for today's QUIC lecture. Thank you so much. Thanks for watching.